Hello, hi everyone. Welcome to the Student the Brand. So this is our sir. Today we are going to discuss about light reflection and refraction. Light reflection and refraction. Okay, let's start. Light reflection and refraction. Light is a form of energy. Light reflection and refraction. Light reflection and refraction. When light incident on the surface, it reflect back. When light incident on the surface, it reflect back. Okay. So the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay. So here you can see. So this is a plane mirror. So I am taking this incident ray and the reflected ray. So and the line which is perpendicular to the plane surface is called normal line. Incident ray and the reflected ray and the line which is perpendicular to the plane surface is called normal line. So incident ray, reflected ray, normal line. Okay. So the angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And the angle between undeviated line and reflected line. So this is the undeviated line. And the angle between this one is called angle of deviation. Angle of deviation. Understood? So here, now we can observe from laws of reflection. So we'll discuss about laws of reflection. Okay. From laws of reflection, incident ray, reflected ray, normal line lies on the same plane. Okay, from laws of reflection, incident ray, reflected ray, normal line lies on the same plane. Okay, so that is the first one. First one is incident ray, reflected ray, normal line lies on the same plane. Angle of incidence is equal to angle of reflection. And so if you are taking the linear angle is 180 degrees. Linear angle is 180 degrees. Understood? Linear angle is 180 degrees. Okay. So that is include of angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Understood or not? So we can write from laws of reflection. From laws of reflection, angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Can we write like this? So here we can take angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of incidence plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. And angle of deviation equal to 180 minus 2 angle of reflection. Understood? Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. Okay. So this is about angle of deviation. So incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Okay, and angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. Understood or not? And from laws of reflection, incident ray, reflected ray, normal line lies on the same plane. From laws of reflection, incident ray, reflected ray, normal line lies on the same plane. Point number 1. And coming to the point number 2, angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Understood? So I hope it is very clear. Now we can see here. Now we can observe. So that is about angle of deviation. Angle of deviation. Now we will discuss about regular reflection and irregular reflection. So regular reflection and irregular reflection. We will discuss about regular reflection, irregular reflection, regular reflection, irregular reflection. Can anyone say where regular reflection takes place? So can anyone say where regular reflection takes place? On which surface regular reflection takes place? Example for regular reflection. Example for regular reflection. Okay. Example for regular reflection. Okay. So regular reflection takes place on a smooth surface. Example, plane mirror. Okay. And also on still water surface of a lake. Water surface of a lake on it. So regular reflection takes place. Coming to irregular reflection. Where irregular reflection takes place? Irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. Example, wall you can say, and cardboard also you can say. Understood? Yes. So now regular reflection and irregular reflection. So I am taking the plane mirror. This is a plane mirror. So the light rays which are incidenting on the surface, these are parallel to each other. The light rays which are incidenting on the surface, these are parallel to each other. After reflection also, light rays will become parallel to each other. Incident light rays are parallel, then also reflected light rays are also parallel to each other. That type of reflection is called regular reflection. Incident light rays are parallel, then reflected light rays are also parallel to each other. So that type of reflection is called regular reflection. Regular reflection. So you can see, so here you can observe these are incident light rays and reflected light rays are also parallel to each other. This type of reflection is called regular reflection. Regular reflection. Regular reflection. Coming to irregular reflection. Irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface. Example, plane mirror like this. Coming to irregular reflection. So I am taking like this. Okay, here you can observe. So here you can observe. Here you can observe. These are the reflected light rays. These are the reflected light rays. These are the reflected light rays, and these are the reflected light rays. Incident light rays are parallel, but reflected light rays are not parallel to each other. Incident light rays are parallel, but reflected light rays are not parallel to each other. This type of reflection is called irregular reflection. Irregular reflection takes place on rough surface. Irregular reflection takes place on wall. Irregular reflection takes place on cardboard. Understood? Yes. So then, now we will discuss about object and image. So now we will discuss about object and image. So let's see here. Okay, so I'm taking this plane mirror. This is a plane mirror now. So I'm taking here. So light rays are coming from the source. These are the light rays coming from the source. After reflection, those light rays are meeting at one point. So this is a real image. And if you are extending those light rays, extended light rays, virtual object. Real image and virtual object. The point of intersection of reflector light rays. So you can see the point of intersection of reflector light rays. Directly reflector light rays are meeting at one point, that is called real image. If you are extending the incident light rays, extended incident light rays are meeting at one point, their virtual object is formed. Virtual object. Understood or not? Virtual object. So next one. So from here, this is the real object. From this point, light rays are coming. After reflection, those light rays are moving away from it. If you are extending those light rays, so here is the virtual image. Virtual image. Understood or not? Virtual image. Virtual image. So the point of intersection of extended reflector light rays. So we are extending the reflector light rays. Extended reflector light rays are meeting at one point. Their image is forming. Okay. So their image is forming. That is a virtual image. Virtual image. So real object and virtual image. Real image and virtual object. So we'll do numericals also. So numericals also will do. Object and image. Object is real, image is virtual, object is virtual, image is real. Understood or not? So we can observe here. We can observe. Okay. So here you can observe. So this is a real image. The point of intersection of reflector light rays. So directly reflector light rays are meeting at one point. Their image is forming. That is a real image. We are extending the incident light rays. Extended incident light rays are meeting at one point. Their virtual object is there. And here you can see. So from this point light rays are coming. So after reflection, those light rays are moving away from it. If you are extending this reflector light rays, extended reflector light rays are meeting at one point. Their virtual image is forming. Their virtual image is forming. Understood? So I hope it is very clear. I hope it is very clear. Okay. So next one we can see. Understood? So next one we'll go to the nature of the image. Nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. So now you can see here. So you can see. So this is the plane mirror. This is the object. This is the object. This is the object. Object AB. Object AB. How many light rays are required to form the image of the object? How many light rays? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. So I am taking here. So if the light ray is passing along the normal line, it reflects back in the same direction. So it reflects back in the same direction. Okay. So here you can see here. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Yes or no? Yes. Minimum light rays are required to form the image of the object is 2. Minimum light rays are required to form the image of the object is 2. Right? Yes. So if the light ray is passing along this line, so it passes and moves in the same direction. Okay. So it passes and moves in the same direction. Understood? So you can, and one more thing we can take like this. After reflection, those light rays will move away from it. And here if the light ray is passing, again it moves in the same direction like this. And here also you can take. Here also you can observe. Understood or not? So here you can observe. Here you can observe if you are extending the incident light rays. So if you are extending light rays like this and like this also. So and here. So the image will form. So this is A dash and B dash. A dash and B dash. Understood or not? A dash and B dash. A dash and B dash. I hope it is very clear. I hope it is very clear. Right? Yes. Okay. So now first point is object is real. Image is virtual. Object is virtual. Image is real. Second one, object distance is equal to image distance. What is object distance? The distance between object to mirror. Okay. So the distance between object to mirror is called object distance. This is the object and this is the image. Sorry, mirror. This is the object and mirror. And the distance between mirror to image is called image distance. This is the object distance and image distance. Object distance is equal to image distance. Understood? And next one, coming to the third one, height of the object is equal to height of the image. And fourth one, magnification of the plane mirror is +1. And fifth one, magnification of the plane mirror is +1. And fifth one, it also shows lateral inversion. Lateral inversion. What is lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. Once again, check here. Object is real, image is virtual. Object is virtual, image is real. So that is point number 1. And the second point is object distance is equal to image distance. Object distance is equal to image distance. And the third one is height of the object is equal to height of the image. Height of the object is equal to height of the image. And coming to the fourth one, magnification of the plane mirror is. So magnification of the plane mirror is +1. Magnification of the plane mirror is +1. And also it shows lateral inversion. And also shows lateral inversion. So what do you mean by lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. So basic example you can observe on the ambulance. The word is written in the format of lateral inversion. When you see in the rear view mirror, it appears proper. Okay? When you see in the rear view mirror, it appears proper. Understood? I hope it is very clear. That is about lateral inversion. So I will ask one question. Which letter does not show lateral inversion? Which letter does not show lateral inversion? You can comment in the comment section. Right from A to Z, capital letters. So right from A to Z, capital letters. Which letter does not show lateral inversion? So do comment in the comment section. Okay, next one. So this is about plane mirror. Plane mirror. Next one. So we will discuss about one more. That is one more. So which letter does not show lateral inversion? Okay, from A to Z, capital letters. So I am asking capital letters. In capital letters, which letter does not show lateral inversion from A to Z? Just so type in the comment section. So if you know the answer. Okay. So next one, we can check spherical mirror. The mirror which is in the form of curved surface So that is called spherical mirror. The mirror which is in the form of curved surface, that is called spherical mirror. There are two types of spherical mirrors. One is concave mirror, another one is convex mirror. One is concave mirror, another one is convex mirror. So concave mirror is in converging nature. Whenever light rays falls on it, it converges the light rays and make it, okay, so falls on the principal axis. And coming to the convex mirror is a diverging mirror. Concave mirror is a converging mirror. Convex mirror is a diverging mirror. Okay, diverging mirror. So whenever light rays falls on concave mirror, it converge and make it falls at okay, at one point on the principal axis. So coming to the convex mirror, whenever light falls on it, it diverges the light rays. It diverges the light rays, and those light rays will move away from the principal axis. Those light rays will move away from the principal axis. Away from the principal axis. Concave mirror is in converging nature. Convex mirror is in diverging nature. Concave mirror is in converging nature. Convex mirror is in diverging nature. Understood? I hope it is very clear. Next. So do like, share and subscribe to Student the Brand if you like the content, if you like the channel, if you like my explanation. So do like, share and subscribe and share to your friends. Ask your friends to join to the class. Okay, classes are going on CBSE grade 10 physics, and grade 11 and grade 12 students also can join, and JEE NEET. So those are attempting. So those students also can join to the class, because here, so all important topics to be discussed. Those topics will be helpful for 11th, 12th, okay, and grade 10, especially grade 10 CBSE students. And so those are upcoming. So those who completed 9th class, for them also it will be helpful. Okay, so now we will discuss about spherical mirror. That is terms related to spherical mirror. Terms related to spherical mirror. So actually it is a part of the sphere. It is a part of the sphere. This is the center of the imaginary sphere. The center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part. Okay. Center of the imaginary sphere in which mirror is a part is called center of curvature. Midpoint of the mirror is called pole. Okay. So midpoint of the mirror is called, this is the midpoint of the mirror is called pole. So the line joining of center of curvature and pole is called principal axis. First one is center of curvature. Second one is pole. Third one is principal axis. Principal axis. And coming to the fourth one, the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. Yes, ma. So grade 11 and grade 12 also I'll teach. So okay. So we'll see. So the distance between center of curvature to pole is called radius of curvature. And coming to the fifth one, after reflection, all light rays will meet at one point. After reflection, all light rays will meet at one point on the principal axis. That is called a focus. Okay. So you can observe, after reflection, all light rays are meeting at one point on the principal axis. Here you can see this point is called focus. So actually principal focus, simply we can say focus. So generally principal focus, simply we can say focus. So the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. So the distance between here to here is focal length. Okay. Focal length. And coming to the next one, aperture. aperture, width of the reflecting surface or diameter of the reflecting surface is called width of the reflecting surface or diameter of the reflecting surface is called aperture. Understood or not? Once again, center of the imaginary sphere in which mirror is a part, center of the imaginary sphere in which mirror is a part, midpoint of the mirror is called pole, line joining of center curvature pole is called principal axis, and radius of curvature, distance between center curvature to pole, and after reflection all light rays will meet at one point on the principal axis called principal focus. Simply we can say focus. The distance between focus to pole is called focal length, and width of the reflecting surface is called aperture. Okay, so okay, so now you can see, so center of curvature pole, principal axis, radius of curvature, focus, focal length, aperture. These are the terms related to spherical mirror. Now, so I am very good. So బ్రహ్మాండంగా ఉన్నాం, బీభత్సంగా ఉన్నాం. ఓకేనా? So next one, ray rules. So I'll discuss about ray rules. Ray rules. Concave mirror, concave mirror and convex mirror. Convex mirror. So extraordinary, marvelous, amazing. Okay, so now concave mirror. First one is, so pole, focus and center of curvature. Pole, focus and center of curvature. One light ray I am taking, it passes through focus. Second one, another light ray is passing. So pole, focus, center of curvature, light ray is passing. After that, and coming to third one, so pole, focus, center of curvature, light ray is passing through center of curvature, it retraces. Coming to the fourth one, so pole, focus, center of curvature, light ray is incident the pole, it reflect back. Okay, these are the ray rules of concave mirror. Ray rules of concave mirror. Okay, so I'll try, but as of now we am teaching physics. In future I may teach. Okay, so now excuse me, sorry for that. So try to understand. So next time I'll try to teach maths, no physics only. Okay, then come to the convex mirror. First one, pole, focus, center of curvature, light ray is coming from infinity, after reflection passes through focus. So second one, light ray is passing like this. Pole, focus and center of curvature, light ray is passing through focus, after reflection moves towards. And third one, light ray is passing pole, focus, center of curvature. Light rays incident at the pole, it reflect back. Light rays incidenting at the pole, it reflects. So if it is passing through center of curvature also, it passes in the same direction. Coming to the fourth one. So pole, focus, center of curvature. So it reflects back in the same direction. I hope it is very clear. This is about concave mirror and convex mirror. Ray rules. Now we will discuss about image formations. Image formations of concave mirror and convex mirror. Let's start. Okay. Still few more points are there. So related to concave mirror, when light ray passing along the center of curvature. So image formations are very important. So we'll discuss about different applications also. Let's start. Okay, object is at infinity, first case. So do like, share and subscribe to Student the Brand. So click on like button. So it reach to the maximum number of students. Just click on like button, students. So those are there in the live class. So just click on like button. So pole, focus, center of curvature. Pole, focus and center of curvature. Object is at infinity. Object is at infinity. One light ray I am taking. After reflection, the light rays will meet at focus. Here and here also. So object is at infinity, image will form at focus, nature of the image is real and inverted, size of the image is highly diminished. Coming to the next one, concave mirror, pole, focus, center of curvature. Pole, focus and center of curvature. Object is placed beyond center of curvature. So here object is placed beyond center of curvature here. One light I am taking like this. After that passes through focus. Another light is passing through center of curvature. Okay, the image will form between C and F. Object is placed beyond C. Image will form between C and F. Nature of the image is real and inverted. Size of the image is diminished. Okay, size of the image is diminished. Understood? Next one. So third one. So object is placed at C. So where image will form and the nature of the image. So I'll ask questions. Let me know. Object is at C. What about image and the nature of the image? So where image will form? What is the nature of the image? Can you let me know the answer? So answer, where image will form? So now you can see object is placed at C. So object is placed at C, image also will form at C. So pole, focus, center of curvature, object is placed at C, image also will form at C. Image also will form at C. One light ray I am taking like this. Another light ray you can take. Object is at C, image also will form at C. Nature of the image is real and inverted, and size of the image is same size. Size of the image is same size. Understood? Yes. Coming to the fourth one. Now, so pole, focus, center of curvature, object is placed between C and F. One light ray I am taking like this, it passes through focus. Another light ray is incident at the pole. After that, those light rays will meet here. Okay. So object is placed between C and F. Image will form beyond C. Beyond C. Nature of the image is real and inverted and enlarged. Compared to the object, image size is increased. Okay. Real and inverted and enlarged. And coming to the fifth one. So object is placed. So pole, focus, center of curvature. Pole, focus and center of curvature. Object is placed at F. One light ray I am taking like this, it passes through focus. Another light ray is incident at the pole. So after reflection, object is at F. Image is formed at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Okay, so highly enlarged. Yes, highly enlarged. Object is placed at F. Image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Okay, next one. Sixth one. So here you'll get virtual erect and enlarged image. Virtual erect and enlarged image. Understood? Virtual erect and enlarged image. So pole, focus, center of curvature, pole and focus. So pole, focus and center of curvature. Okay. So object is placed between F and P. How many light rays? One light ray I am taking like this, it passes through focus. So another light ray is incident at the pole, it reflects back. And if you are extending these light rays, extended light rays will meet behind the mirror. Okay, so here you can observe these light rays will meet here. So here, so the image will form virtual erect and enlarged. Virtual erect and enlarged. Understood? Object is placed Object is placed between P and F. Image will form behind the mirror. Behind the mirror. Behind the mirror. Nature of the image is virtual and erect. Nature of the image is virtual and erect. Size of the image is enlarged. Compared to the object, image size is increased. Compared to the object, image size is increased. So that is erected and enlarged image. Okay, enlarged image. Compared to the object, image size is increased. So that's why it is called enlarged image. So this is about concave mirror. So now we can see, now we can observe, object is placed. So you can see convex mirror, diverging mirror, la 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 la. Object is at infinity, image will form at F. Nature of the image is virtual and erect. Size of the image is diminished. Object is placed. Okay, object is placed. Object is placed at infinity. Image will form at focus. Nature of the image is virtual, erect, and size of the image is actually highly diminished because point size image is formed. Highly diminished. That is nothing but point size image is forming. Point size. Okay. So point size image is formed at focus. And next one, coming to one more. So you can see here, pole. This is the pole. Focus, center of curvature. Object is placed. So you can go through it. So here you can see, and here also you can see. So if you like the content, if you like the channel, please do like, share and subscribe to Student Day Brand. If you like the content, you can go for super chat, super thanks, and so you can check the goal also. Super thanks, super chat, and you can go for membership also. Just check once. So check once the channel. So if you want to support the channel, you can go for super thanks, super chat, and so go for membership, right? And subscribe. Do like, share, and subscribe, and inform to your friends. Ask your friends to join to the class. Okay. So it passes through focus. And here also the image will form between P and F. The image will form between P and F. Okay. Object is placed between P and infinity. Image will form between P and F. Nature of the image is virtual and erect. Size of the image is diminished. Now here we can say diminished. Now we can say yes, diminished image. Okay, diminished. Compared to the object, image size is decreased. Okay, done. Next one, sign conventions. New Cartesian, sign convention, new Cartesian, sign convention, all distance measured from the pole. Distance opposite to along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. Okay, so here I'm saying this is a concave mirror. Concave mirror, converging mirror, full focus, center of curvature. Full focus, center of curvature. Full focus, center of curvature. So, along the incident rays, object distance, image distance, focal length, radius of curvature, all are positive. All measurements will be taken from the pole. In the direction of incident rays, all are positive. Opposite to incident rays, all are negative. Above the principal axis, all are positive. Below the principal axis, all are negative. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. Okay, so like that we can. So all measurements will be taken from the pole. In the direction of incident rays, all are positive. Opposite incident rays, all are negative. What are those distances? All distances are measured in the direction of incident rays, positive. All distances are measured in the direction of opposite incident rays, negative. Above the principal axis, positive, and below the principal axis, negative. Yes. Understood? I hope it is very clear about it. These are the new Cartesian sign convention. New Cartesian sign convention. Okay. Now. Mirror formula. Magnification. 1 by f equal to 1 by v plus 1 by u. Mirror formula. Magnification is height of the image by height of the object. That is equal to minus v by u. Mirror formula is 1 by f equal to 1 by v plus 1 by u. Okay, and magnification is height of the image by height of the object. Okay, understood? I hope it is very clear. So many are there. So next one, refraction of light. Refraction of light. Refraction of light. Refraction of light. What is the refraction of light? The bending of the light ray at the interference of the two media. The path of the light changes. The path of the light changes at the interference of the two media is called refraction. Refraction. If refraction. What is that? Refraction. The path of the light changes at the interference of the two media is called refraction of light. Okay, so you can see here. So I'm taking this the rarer medium and denser medium. In rarer medium, speed of light is more. In denser medium, speed of light is less. When light ray is passing from rarer to denser, it bends towards the normal line. Okay, so here, if the light ray is passing from rarer to denser, so it bends towards the normal line. If the light ray is passing from denser to rarer, it moves away from the normal line. So the angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle of refraction. Understood? Now you can see here. So when light ray is passing from rarer to denser, the light ray will bend towards the normal line. The light ray will bend towards the normal line. So in the case 1, so angle of incidence is greater than the angle of reflection. Angle of incidence is greater than the angle of refraction. Angle of refraction, because when light ray is bending towards the normal line, so light ray is bending towards the normal line. Okay, so you can observe, if the light ray is passing from rarer to denser, bends towards the normal line. Understood or not? Okay, done. So check once here. So then angle of incidence is greater than the angle of refraction. Angle of incidence is greater than the angle of refraction. So point number 1. And coming to the next one. So these are rarer medium, denser medium. If the light ray is passing from denser to rarer, the angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. Angle of refraction. Understood or not? So now angle of refraction is greater than the angle of incidence. Angle of refraction is greater than the angle of incidence. So that is in case 2. Understood? In case 2, angle of refraction is greater than the angle of incidence. Angle of refraction is greater than the angle of incidence, because when it is passing from denser to rarer, it moves away from the normal. Denser to rarer, it moves away from the normal line. Understood or not? So if it is passing from denser to rarer, it moves towards the normal line. If it is passing from rarer to denser, it moves towards the normal line, because speed is decreasing. Understood? So speed is if it is passing from rarer to denser, speed is decreasing. That's why it is moving towards the normal line. Understood or not? Okay, if it is passing from denser to rarer, it moves away from the normal line. It moves away from the normal line. Understood or not? Check once here. Next. So now next one. Next one. So here if you are taking rarer medium, denser medium, light ray is passing from rarer to denser. Okay, so at the interference, so it moves away from the normal line. This angle of incidence and angle of refraction. Angle of incidence and angle of refraction. Understood or not? So here you can observe if the light ray is passing from denser to rarer, at interference between rarer to denser, it passes along the normal line. The angle between incident ray and normal line is called. So it making angle, okay, refracted ray making 90 degrees with a normal line. Refracted ray is making 90 degrees with a normal line. Understood or not? So at certain angle of incidence, the refracted ray makes 90 degrees with normal line, or the refracted ray passes or gauges or moves along the surface. Understood? That angle is called critical angle. The angle at which, so angle of incidence is, that is nothing but critical angle. The angle at which the refracted ray passes or gauges or moves along the surface, okay, are making 90 degrees with the normal line, that angle is called critical angle. Understood? So, and one more thing, if the light ray is passing from denser to rarer, so this angle of incidence is equal to angle of, so critical angle actually. So if it is passing from denser to rarer, so it makes more than 90 degrees. This is angle of incidence and this one is more than 90 degrees with a normal line. Okay, more than 90 degrees, then light ray reflect back into the same medium. Light ray will reflect back into the same medium. If light ray is passing from denser to rarer, understood or not? Here you can observe, so denser medium, rarer medium. Light ray is passing from denser to rarer, so it moves away from the normal line. So if it is passing from denser to rarer at certain angle of incidence, the refracted ray passes or gauges along the surface or moves along the surface or making 90 degrees with the normal line. Okay, that angle is called angle of critical angle. Okay, that is called critical angle. We can say critical angle. And here you can see, so the refracted ray makes more than 90 degrees, then it will be reflected back. The refracted ray makes more than 90 degrees, then it will be reflected back. So that phenomenon is called total internal reflection. So the angle at which the refracted ray passes or gauges or moves along the surface, that angle is called critical angle. So refracted ray makes more than 90 degrees, then that light ray reflects back into the same medium. Then this phenomenon is called total internal reflection. Understood? Next one. That is glass slab. Okay, so here you can see this is a glass slab. So light ray is passing from rarer to denser. This is a normal line. Light ray is passing from rarer to denser, and again it is moving away from it. Okay, so the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. And angle between incident ray, so it is parallel to the emergent ray. Angle between emergent ray and normal line is called angle of emergence. Okay. Okay, I hope it is very clear. Just check once. So incident ray, refracted ray, emergent ray. Angle between incident ray and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Angle of emergence. Understood or not? So if the light ray is passing along the normal line, so if it is passing along the normal line, no refraction takes place. If the light ray is passing along the normal line, no refraction takes place. And one more point. So the two mediums, if two mediums refractive index is same, if two mediums refractive index is same, then no refraction takes place. No refraction takes place. Understood? Understood or not? I hope it is very clear. Next one. So this the angle between, so the distance between emergent ray and initial direction of the incident ray. Emergent ray and initial direction of the incident ray is called lateral shift. Lateral shift. Understood? Lateral shift or lateral displacement. The distance between emergent ray and initial direction of the incident ray is called lateral shift or lateral displacement. I hope it is very clear. Understood? Our next one. So this is a beaker. I am taking this a beaker. So the person is here. The person is here. Understood? So coin is placed at the bottom of the beaker. Coin is placed at the bottom of the beaker. Initially the person can't able to see the coin. Okay. So coin is placed in the beaker. Later after pouring water, the coin position rises up. So the coin position rises up. So until here, the coin position rises up. This is the coin position. So the distance between actual position to apparent position is called vertical shift. The distance between actual position to apparent position of the coin is called vertical shift. Vertical shift. I hope it is very clear. Lateral displacement is nothing but the distance between emergent ray and initial direction of the incident ray. Okay, initial direction of the incident ray and emergent ray is called lateral shift. And coming to the next one, here you can observe the distance between actual position to apparent position of the coin is called vertical shift. Vertical shift. Understood? So here if you place the pencil in the beaker, so water is filled here. Understood? So the pencil is placed. Here. So at the interference between water and air, the pencil appears to be bent. Okay. The interference between water and air, pencil appears to be bent. Actually, so pencil is like that only, same position. So it appears like this. But actual position is here itself. Okay. So it appears, this is actual, it appears like this, somewhat bent like this. Okay, like here. But this actual position, due to refraction of light. And if you place lemon in the beaker, so a glass. Okay, so water is poured. So if you place the lemon inside of it, okay, it appears bigger. So if you place the lemon inside of the glass of water, so it appears bigger due to refraction of light. I hope it is very clear. So the distance between emergent ray and initial direction of the incident ray is called lateral shift. And if you place the pencil in the beaker at interference between water and air, it appears to be bent. And here if you take coin and so the coin is placed in the bottom of the beaker. So the vertical distance between actual position to apparent position. This actual position is at the bottom. This apparent position. So the distance between actual position to apparent position is called vertical shift. Okay, I hope it is very clear. So this is about refraction. And coming to the laws of refraction. We'll discuss about laws of refraction. Laws of refraction. Laws of refraction. Laws of refraction. So this is rarer medium, denser medium, light ray, incident ray, and this one is the normal line, and this is the refracted ray. Angle between incident and normal is angle of incidence. Angle between refracted and normal line is called angle of refraction. Okay. So now. So laws of refraction. Laws of refraction. Laws of refraction. Come to the laws of refraction. Incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. Point number 1. Coming to point number 2, sine of angle of incidence to sine of angle of refraction equal to constant. That is nothing but n. Sine of angle of incidence to sine of angle of refraction equal to constant. That is nothing but n. That is called refractive index. Refractive index. Understood? The ratio of sine of angle of incident to sine of angle of refraction equal to constant. That is nothing but refractive index. So n equal to C by V. That is called absolute refractive index. N equal to C by V. That is called absolute refractive index. Coming to relative refractive index. Okay. So absolute refractive index is nothing but, so the ratio of speed of light in vacuum by speed of light in medium. So the ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. So coming to relative refractive index. So speed of light in medium 1 by speed of light in medium 2 is called relative refractive index. Relative refractive index. Right? Lenses, spherical lenses. Now we'll discuss spherical lenses. So convex lens and concave lens, convex lens and concave lens. Here you are taking this convex lens. So it is a part of this one, this one, this one, this one. Optic center F1, 2F1, F2, 2F2. Convex lens. Coming to concave lens, concave lens. Convex lens and concave lens. So do like, share and subscribe to Student the Brand. If you like the content, if you like the channel, so do like, share and subscribe. Now you can see concave lens, convex lens and concave lens. Now we will discuss about ray rules. Ray rules, ray rules, ray rules, ray rules, ray rules. Optic center F1, 2F1, F2, 2F2. Okay. So one light ray I am taking. After refraction it passes through focus. So after refraction passes through focus, first one, Coming to the second one. Optic center F1, 2F1, F2, 2F2. Light rays passing through focus after refraction. It will become parallel to the principal axis. And coming to the third one. So third one, light ray is passing like this. So if it is passing through optic center, so optic center F1, 2F1, F2, 2F2. Light ray is passing through optic center, so no deviation takes place. So that is about convex lens. Coming to concave lens. So do like, share and subscribe to Student the Brand. So if you like the content, if you like the channel, please do like, share and subscribe to Student the Brand. So share to your friends. So share to everyone. So please spread one word regarding the channel. Okay, so there is a channel Student the Brand. So physics classes are going on. Just inform to everyone. Ask them to join to the class. Okay, so make sure that so share to everyone and click on like button and subscribe the channel. So if you want more videos regarding the physics class, so live class updates, everything will get it. Just if you click on like button and so click on subscribe button and click on bell icon also. Okay then. Optic center F1, 2F1, F2, 2F2. Light ray is coming after reflection passes like this. So first one coming to the second one. Light ray is passing. Optic center F1, 2F1, F2, 2F2. So third one. Optic center F1, 2F1, F2, 2F2. Optic center, light ray is passing through optic center. No deviation takes place. So dear students, so please do like, share and subscribe to Student the Brand. So inform to all your friends. So ask them to join to the class. Share to everyone. Share to all your friends. Those are there in your school, college. Spread one word regarding the channel. So just I need your help to reach maximum number of students. So without your help, I can't able to reach to the maximum number of students. So I need your help. Spread one word regarding the channel. So just click on like button, click on share button and click on subscribe button. So I'm doing lot of hard work to reach maximum number of students. So please help me in that to reach maximum number of students. Okay, so share to our friends, share in our groups, share to everyone. Okay, ask them to join to the class, ask them to listen the class. If they like the channel, if they like my explanation, please ask them to subscribe. Okay, so I need your help, I need your support. So please spread one word regarding the channel. Share to everyone as much as possible, as soon as possible. Okay. So please, I need your support. So please do like, share and subscribe and inform to everyone. So help me in that to reach maximum number of students. Okay, coming to the next one. So convex lens. So optic center F1, 2F1, F2, 2F2. Object is at infinity, image will form at F2. So one light I am taking like this, another light I am taking like this. After that, so those light rays will meet at focus. Object is at infinity, image will form at F2. Nature of the image is real and inverted. And size of the image is highly diminished. So point number 1. Coming to the point number 2, image formations. Optic center F1, 2F1, F2, 2F2. Okay, so object is placed beyond 2F1. Image will form between F2 and 2F2. Nature of the image is, so here you can see, the image will form between F2 and 2F2. Understood? Object is placed beyond 2F1. So image will form between F2 and 2F2. Nature of the image is real and inverted. Size of the image is diminished. Compared to the object, image size is decreased. Real and inverted, size of the image is diminished. And coming to the third one, object is placed optic center F1, 2F1, F2, 2F2. Object is placed at 2F1. One light ray I am taking like this, it passes through focus. Another light ray is passing through optic center. The image will form between 2F2 and F2. So the image will form at 2F2. Object is at 2F1. Image will form at 2F2. Nature of the image is real and inverted. So dear students, please do like, share and subscribe. So I need your help to reach maximum number of students. Subscribe the channel, share to everyone, ask your friends to join to the class. So please subscribe and share as much as possible, as soon as possible. So I want your help. Okay, so to reach maximum number of students. Okay, to reach maximum number of students, I need your help. So like, share and subscribe and spread to everyone and share this link to everyone and ask them to join and check my videos. You can check my videos, channel videos. If you like the content, if you like the explanation, if you like my videos, you can share to everyone. So I'm doing lot of hard work. So without your support, that work will not useful. It cannot convert into fruitful results. So please share to everyone, inform to everyone. So make this channel to reach everyone. That is in your hands only. So try to support the channel. Try to encourage the channel. If you like the content, if you like the explanation, please do like, share and subscribe. Okay. So this is the third one. And coming to the fourth one. Fourth one. Dun, dun, dun. F1 to F1, F2 to F2. Object is placed between 2F1 and F1. One light I am taking like this. It passes through. Another light ray is passing through optic center. That image will form beyond 2F2. Okay, object is placed between 2F1 and F1. Image will form beyond 2F2. Nature of the image is real and inverted. Size of the image is enlarged. Here, so image is real and inverted and same size. Okay, so same size of the object will form at 2F2. Okay, so that's enough. So next two cases are there, we'll see. So next object is placed at F. So optic center F1, 2F1, F2, 2F2. Object is placed at F1. One lighter I am taking like this, passes through focus. Another lighter is passing through focus. Okay, object is at F1. Image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. So image will form at infinity. Image will form at infinity. And coming to the last one, so this is fifth. Sixth one is very important. So sixth one, optic center F1, 2F1, F2, 2F2. Object is placed between F1 and O. One light I am taking like this. It passes through focus. Another light ray is passing through optic center. If you are extending these light rays, those light rays will meet here. Object is placed between F1 and O. So image will form same side of the object, same side of the object. Okay. Nature of the image is virtual erect. Okay. Same side. So because this side only image will form virtual and erect. Virtual erect and enlarge. Compared to object, image size is increased. So this is the last case. And coming to the concave lens. Concave lens, only two cases are there. Optic center F1, 2F1, F2, 2F2. So one light I am taking like this. After that it will passes. Another light I am taking like this. It will pass. If you are extending those light rays will move. Object is at infinity. Image will form at F1. Nature of the image is virtual, erect and highly diminished. Nature of the image is virtual, erect and size of the image is highly diminished. So that is the first one. Coming to the second one. So only two cases, only in convex lens, concave lens. Optic center F1, 2F1, F2, 2F2. So object is placed anywhere between optic center and infinity. One light I am taking, it passes like this. Another light ray passes through optic center. The image will form between F1 and O. Object is placed between optic center and infinity. Image will form between F1 and O. Image will form between F1 and O. Okay. So nature of the image is virtual, erect and diminished. Compared to the object, image size is decreased. Understood or not? Okay. So dear students, so please help me in that to reach maximum number of students. So spread the channel. Those who are subscribed, so inform to everyone. Those who are need to subscribe, please do subscribe. Those are in the live, do like, share and subscribe to Student Brand. So share to everyone, inform to everyone, ask your friends to join to the class. spread a one word regarding the channel. I need your help, I need your support to reach maximum number of students. So help me in that to reach maximum number of students. I'm doing lot of hard work. That hard work should reach to the maximum number of students. With your support only, I can able to reach to the maximum number of students. So try to help me in that. Inform me, inform to everyone, those who are there in class, grade 10, grade 11, grade 12. So indirectly it will be helpful for them, okay, because it's related to subject, so related to content, you can check the content. So I'm not asking you to immediately spread one word and inform. So observe the content, check the content, subscribe the channel, check the videos, content related videos. If content is good, kindly do like, share and subscribe. And if you like the content, if you like the channel, if you like my explanation, please share to everyone, inform to everyone. Observe the content. If content is not good, then that is your choice. So check the content, whether whatever I'm explaining, is it correct content or not. So it will be helpful or not, it is useful or not, it is there or not. Check once. Check the content. So I'm telling to you only, so check the content. So verify the content with the help of textbook. CBSE grade 10 physics. Sorry, science textbook. Check the CBSE grade 10 science textbook. Check. In that physics topics, light reflection, refraction, human and colorful load, magnetic effects of electric current and electricity. So whatever topics I am teaching, so you can take the book and keep in front of you and check whatever I am explaining, those topics are there in our textbook or not, those content is there in our textbook or not. So whether it is correct or not, check once. Check. So if it is correct, if you like it, if you like the channel, if you like my explanation, if it is truly helpful to you, if it is worthy, the content is worthy, the subject is worthy, so explanation is good. So if you like it, please do like, share and subscribe. From your side, you can do it first, then you can after that you can spread regarding, spread a word regarding the channel, share to your groups, share to your friends. Okay, so your friends group, so you can inform to your friends, ask them to share to remaining students, ask them to join and check the videos, ask them to join and see the videos. Okay, so just check the channel. So there are many videos, so many videos are there, nearly 5.6 K videos are there. Okay, so 5,600 videos are there. Just check once, you can check the videos. So all are related to physics content only. So check the channel, check the videos. So inform to everyone, ask them to join to the class. So I need your help, I need your help. Help me in that. Please subscribe the channel. So subscribe the channel, check first, subscribe and check the channel. Okay, and check the channel and subscribe also. Okay, so if you subscribe, then you will be, it is available with you, then automatically you can check whenever you want. So subscribe the channel and check the channel. So if it is good, if it is liked, so you can share to your friends. So ask your friends to join to the class. Okay, help me to reach to maximum number of students. I need your support, I need your help in that. Okay, so without your support, definitely I can't reach to the maximum number of students. Please help me in that. Okay, so I'm requesting everyone, so try to support the channel, encourage the channel, spread the channel and inform to everyone, maximum number of students. I wanted to reach to the maximum number of students. So as much as possible, as soon as possible, because the exams are coming up. So this content is very helpful to them. So important topics will be teaching, important content I'll be explaining. Okay, so where we'll get marks, what type of questions they will ask, and everything I'm explaining. Practice sessions are there, questions practice will be there. So in the previous morning and before that, yesterday also, I took the practice session. Okay, so explanation session is going on continuously. So throughout maximum all the day, maximum. Okay, so here and there little gap, remaining time maximum I'm taking the classes, live class, that too live classes only, interacting with the people, those so whoever asking doubts, I'm responding to those doubts also. Okay, and I'm asking questions also, like a quiz. So like everything, so everything is involved in the live class only, So In the live class only I am teaching the class. So try to inform to everyone. So share this link to everyone. Ask your friends. Ask your okay na. So whoever it is 10th, 6th, 7th, 8th, and 9th, and 11th and 12th, and JE NEET, whoever there. Okay, this content is helpful for them. Everyone. This content is helpful. Right from 6th standard until 12th standard. Okay, and those are writing for JE and NEET also. Whatever I am explaining, that content is helpful. Okay, so inform to everyone, maximum number of students. I wanted to reach maximum number of students. Please subscribe the channel, share the channel. Okay, so I hope it is very clear. So it will be helpful to you. First of all, you check the channel, you check the content, So if parents are watching, please, I'm requesting parents also. So please check the channel and verify the channel, all the videos, whether content is good or not, check. Then only you can subscribe the channel and share to everyone. So I need your support. Whoever watching, whoever observing the channel, please try to share it everyone as much as possible, as soon as possible. So make the channel to reach maximum number of students. So thank you so much for joining and attending and listening my class. So this is your Siva sir. So if you like the content, if you like the channel, please do like, share and subscribe to my Student the Brand channel. Thank you so much. We'll see you in the next class. Thank you.